All right, let's talk about something you probably do all the time without a second thought. You click a button online and poof, something happens. But have you ever really stopped to wonder what's going on behind the scenes? Today, we're going to pull back the curtain on one of those simple clicks and follow its wild, invisible journey through the cloud. So picture this. You just canceled a calendar invite. For you, it's one tap and it's done. But what you've actually done is kick off this incredible high-speed chain reaction between a bunch of different systems. In this explainer, we're going to follow that single click and see exactly where it goes. We're going to break this down into 5 quick parts. We'll start with that initial click. Then we'll meet the cloud crew that handles the job. We'll follow your request step by step, figure out what happens when things go wrong, and wrap up with why this whole system is just so smart. Okay, part 1, a simple clicks journey. It all starts with you. That single tap is the spark that ignites this entire automated process. The thing to realize is that your click isn't just one command. Nope. It's the start of a lightning-fast, totally automated conversation between a whole team of powerful cloud services. It's like you're a director shouting action on a movie set. So who are these services? Who's in this cloud crew? Well, think of them as a highly specialized team, a cast of characters where everyone has a very specific job to do. Let's meet the stars of the show.
Okay, let's run through the crew. First, you've got Amazon SQS. This is our mailroom. Its whole job is to grab your request and hold on to it so it can't possibly get lost. Then there's AWS Lambda. That's the brains of the operation. It's the one that actually runs the code to cancel the event. Next is Amazon DynamoDB, which is basically a super fast digital filing cabinet that stores all the event info. And last but not least, Amazon SNS. Think of this one as the town crier, shouting the news of the cancellation to anyone and everyone who needs to know.
All right, we've met the crew. Now for the fun part. Let's actually follow your cancellation request as it makes its way through this whole system. So, the second you click cancel, your request lands as a message in the SQS mailroom. It just sits there, waiting safely in line. Now, the moment that message arrives, it acts like a doorbell, automatically triggering our brain, AWS Lambda, to wake up and get to work. Lambda's first job, it zips over to the DynamoDB filing cabinet and says, hey, find me the record for this specific event.
So once Lambda has the right file, it does 3 really quick things. First, it changes the status to canceled. That's the most important part, right? Then it adds a new timestamp, so there's a perfect record of exactly when the cancellation happened. And finally, it bumps up something called a sequence number. That's just like version control, changing a file from V1 to V2, so everyone knows this is the newest version. With the changes made, Lambda saves the updated file back into the DynamoDB filing cabinet. Then it turns to our town crier, SNS, and says, okay, spread the news. And then, and this is a really crucial final step, it goes all the way back to the mailroom and deletes the original request message. Why? To make sure this whole process can't accidentally run a second time. It's just good housekeeping.
Now, that all sounds great when everything goes smoothly. But we all know technology isn't perfect. You're probably thinking, what happens if one of these pieces breaks down for a second? I mean, what if the database is down from maintenance right when Lambda tries to save the file? Does your requests just get lost in cyberspace? The answer is a hard no, and that's because this system has a brilliant safety net built right in.
This is where our mailroom SQS becomes the hero. Remember that last step where the message gets deleted? Well, that only happens if every single step before it was a success. If anything goes wrong, if the database hiccups, if the code has a bug, that delete command is never sent. The original message just stays right there in the mailroom queue. Safe and sound, ready for the system to automatically try again later. Your request is never lost.
And this isn't some happy accident, it's a core part of the design. The system's own documentation literally says that failed tasks are designed to trigger retries. This whole thing is built for resilience, to make sure that even with temporary glitches, the job will eventually get done. So let's just zoom out for a minute. Why go through all this trouble? Why have a mailroom and a brain and a filing cabinet? Why not just have one big program do everything? Well, it all comes down to the big picture. This design gives you 4 huge wins. First, it's unbelievably reliable because of that mailroom safety net we just talked about. Second, it's scalable. It doesn't care if it gets 10 cancellations or 10 million. The system can handle it. Third, it's super efficient. These services only spin up when they have work to do, which saves a ton of computing power. And finally, it's easy to maintain. If something breaks, engineers know exactly which part of the system to look at to fix it.
And that is the real magic here. All of this invisible, elegant complexity is happening in the background for one reason and one reason only: to make your experience on the front end feel simple, fast, and totally bulletproof. The best technology is the kind you never even notice.
It really makes you think, doesn't it? The next time you send a text or like a photo or just refresh a web page, take a second to imagine that invisible symphony of services, like our cloud crew, all working together in perfect harmony just to make it happen. What other digital magic is hiding right in front of us?